Hey guys, Jason from Toronto, Canada. I've got a great Yachtmaster question for you guys. If any of you have been following any of the other Yachtmaster videos I've been doing, you know that I'm doing an online course through oceantraining.com. Ted Miley is the principal there, and he emailed the package over to me from the UK. I'm happy to say that I passed the exams, the theory exams, and in fact I'm due to do the practical in Nova Scotia this weekend actually, so it's all finally coming to a head, coming to an end. This is a fairly lengthy question. It covers a lot of navigational aspects, which is why I'm doing this one in particular. It's fairly lengthy. I'm going to try to blast through this as quickly as I can. But for those of you who are doing an online course or you're preparing for any kind of sort of nautical exam, whether it's RYA Yachtmaster or not, this is a really good example. So without further ado, let's get going on this. So here's the question. They're asking us to prepare a passage plan for a voyage from Bramhope Creek to Farlow River, Tuesday the 28th of May. Okay, it's telling us our draft is 1.4 meters, our air draft is 4 meters, and the boat speed is 12 knots. Okay, there's an obstruction at the entrance, so we need to know what the earliest time would be able to pass. The obstruction is Bramhope Bar, and it's 0.7 meters. Okay. And at the other end, at Farlow, we're going to have to figure out if we can pass under a rail bridge. So let's get deeper into the question here. Part A. So what time in the morning on the 28th of May can we cross, will we be able to cross Bramhope Bar with a required clearance or a desired clearance of 2 meters? Okay. Part B, the plan should include the distance. Okay, so we're obviously going to have to plot the course. And as I've already said, we want to know the departure time from Bramhope Creek, and of course our ETA on the other side at Farlow River. As we're plotting our course, of course, we have to take into consideration tidal streams and navigational hazards along the way. And when we get to the final part of the question, when we get to Farlow, can we proceed directly to the Upper Town Quay on arrival? So once we get there, will we have enough water below our keel to pass under the rail bridge at Farlow? All right, so those are our questions. So let's get right into what we need to do here. So we're leaving Bramhope Bay, right? In this case, we're going to be coming up Bramhope Creek, okay, up here. How do we figure out depth of water? Okay, because that's ultimately what we need to know. We need to know the high water at Bramhope to be able to figure out when we can pass in the morning, the earliest we can pass with a desired clearance of 2 meters. So first thing we do is we go to our tidal almanac here and we go to Bramhope. Okay, now what do we notice? Bramhope, we notice, is a secondary port. So it tells us to get our high water information first from Victoria, which is a standard port. And then once we get the information there, then we can apply these differences in time and depth, tidal depth, to get to high water at Bramhope. So here we go. We go to Victoria. Okay, we go to May the 28th. We want to find high water for the morning, so we get our earliest high and low water. Okay, high water 1125 at 5.5 meters, low water 0509 at 0.6. Okay, so what we do is we start filling in our information on our secondary port tidal prediction form, and this I just downloaded from the internet. You can get blank forms for this. Okay, so we put in our date, Victoria, standard port, Bramhope, secondary port. So Victoria, by looking at our numbers over here, we know high water is 1125 at a height of tidal height of 5.5, and low water 0509 at a tidal height of 0.6. Okay, now we subtract 0.6 from 5.5 to get 4.9, and that's our tidal range. Okay, we go back to the chart. We go to our chart. Excuse me. To our tidal graph here. Okay, and we can see that our tidal height of our tidal range of 4.9 coincides directly actually to springs. Okay, so we know when we come back here to do our calculation that the red line is the one that we're going to be concerned with. All right, so we have our time, our time of high water, our height of high water. So we go back to Bramhope Creek, okay, and we look at the information we're given. So we have these times here for high water, all right? We can either fit our time, okay, of 1125 between these two numbers, or these two numbers diagonally, or these two numbers here. So we see our time of 1125 falls between 0600 and 1200. Okay, we go to, and so let's take a look here. We've got a time difference first of negative 0006 minutes. Okay, why? Because it falls under this column. That's our start. We go to the graph. On the top section of the graph, we put in 0600. Okay, that's our hour, right? And then we plot in 1200 at the top here. Okay, so that's those are our two times. Okay, and in the middle we put 7, 8, 9, 10, 11, and 12. And of course we know that this is 0700, 0800, and so on and so forth. Okay, now we go to our differences in minutes here, okay, and the difference in minutes, okay, negative 0006 minutes, okay, falls in line with our first time here. So that's the first thing we put on the bottom portion of our graph, 0006 minutes, and we know the top end is plus for our difference in time, in minutes, it's plus 0006. So we put our first number in, 0006 minutes, 5, 4, 3, 2, 1, okay, 0, then we're into plus, and of course this is plus, just in case you're wondering why it's only 0, 1, I simply eliminated some of the zeros, right? So plus 0, 1, 2, 3, 4, 5, 6. Okay, so we've gone from a negative 6 to a plus 6. So our time, 1125, we find up on the top line. Okay, so this is in hours, right? 11 to 12, okay, 1 full hour. So we know 30 minutes falls somewhere in between, and slightly less is 1125. We mark that off. Okay, we take our, and we've already drawn a line from 1200 to plus 0006 minutes, right? We take our parallel rulers, line it up with our first line, and walk it over slightly to our mark, to where we've marked off 1125. Okay, draw the line, and that line falls down here onto 5. Okay, so what that means is we go back up here, and for our time, we know the time difference is plus 5 minutes, which gives us a high water at Bramhope as 1130. Okay, for our height of tide, we simply go up back here, okay, and we can see mean high water springs. We know we're dealing with springs, so the difference is plus 0.3. Okay, so we simply plug in plus 0.3. That added to 5.5 gives us a new height of tide at depth of water at 1130 at Bramhope as 5.8 meters. Okay, now what we do is we use this information and we go back to our tidal curve, okay, at Victoria, because Bramhope doesn't have one, okay. We take our high water, okay, along the top, okay. We mark that off at 5.8, so 5, 1, 2, 3, 4, 5, 6, 7, 8, 5.8, and down here on the bottom where it says low water, 0.6. Okay, attach the two with a line. Okay, now what we do at the bottom here, okay, we mark off 11:30 as our high water time, okay, and we know we want to leave earlier than 11:30, obviously, so we're going backwards here, okay, so 10:30, we fill in for 9:30, 8:30, 7:30, okay. Now what we do is we want to figure out, we want to factor in the information we've been given about the boat itself, specifically the draft, and the fact that we want to have at least a 2-meter clearance below our keel as we're crossing Bramhope Bar. All right, so what we do is we know that our draft is 1.4 meters, okay? The clearance we want is 2 meters. We add those two together to get 3.4 meters, okay? We subtract the height of Bramhope Bar, okay, which is 0.7 meters, and that new figure we get is actually the height of tide that we need, okay, in order to be able to pass safely with 2 meters under our vessel, okay? So we now have a depth of tide, so we go back up to our tidal graph, okay, and now we plug in the 2.7 meters, okay, tidal height. Mark that off. We draw a line straight down to the diagonal that we drew between low water and high water, and then from that point we draw straight over to the red line because we know we're dealing with springs, right? From that point we go straight down and we see where it falls. Okay, so this box says 0730, okay? This line here represents that time, okay? This line here represents 0830, this line represents 0930. Okay, so that's a full hour, 7:30 to 8:30. So halfway through, okay, is half an hour, right? So, which means that this is 8 o'clock, the lighter line. Our line came down just slightly inside of that, okay? So between 7:30 and 8 o'clock, you have two smaller lines. That represents 10 minutes, that represents 10 minutes. So 7:30, 7:40, 7:50, our line comes down between the two. So now we have a departure time of 0755, okay? So we know that at 0755, we can cross Bramhope Bar safely with 2 meters under our keel. Okay, so now that we have that, we've basically answered the first question, right? At what time in the morning will the vessel be able to cross Bramhope Bar with the required clearance? Okay, now let's move on. We want to know distance. So let's clear this away here. So for distance, obviously you have to plot your course, okay? And I just did it freestyle. But what I did, however, is I took a look along the route, okay, to find out what any navigational hazards would be. We can see here we have to keep clear of the overfalls just off of West Point. Okay, we've done that. Come down here and across. We need to stay clear of Robinson Rock, and we've done that. We're well away from that. And of course, all traffic separation schemes must be considered as a navigational hazard. Okay, small craft, first of all, you don't want to be in the traffic lanes. You want to be on the outside of it. okay? And you need to remember you need to cross at a 90-degree angle. That's the fastest way to cross a traffic separation scheme where you've got big ocean liners zooming back and forth, okay? So I've taken the course past it before continuing north, and then here we are coming into Farlow. You take your handy dividers, okay, and you measure it off. In this case, we discovered that the distance of our plotted course is 45 nautical miles. So we have our distance now, okay? Now we want to find out how fast we're going, okay? We're told that the boat speed is 12 knots. However, we have to consider that we're in tidal waters, so tide will be affecting us either positively or negatively. So how do we find out the speed of drift? Okay, how do we find out about tidal streams? Well, we go back to our tidal graph for Victoria, okay, where we're able to calculate our time, and we can see now the hours before or after time are given to us here. In our case, we are in the hours before high water, -1, -2, -3, -4. Our timeline falls just inside -4 hours before high water, okay? So that's where we know where to begin when we go to our handy tidal stream atlas, okay? And this is how we determine set and drift, okay? So because we're at the tail end of -4 hours before high water, we're simply going to begin at -3 hours, okay? We're going to be here somewhere, okay? There's Bramhope Creek where we're going to be coming out of, okay? We have of course, the first number, 2.0, is Neeps. Second number, 3.9, is Springs, right? So we've got 3.9 and 3.4 here. Let's call it, say, 3.6, okay? We carry on along the direction of the course that we've plotted. We'll be around here somewhere in -2 hours before high water. We have a figure of 3.6, 3.4. Let's call it 3.4. Okay, 1 hour before high water, we're going to be down here somewhere. We've got Springs as 3.4, okay? And carrying on, we're looking at, as we get closer to Farlow, this is at high water. It's 2.6. So what we're going to do is we're going to say that there's an average of 3 knots following us. In other words, we're going to be pushed an additional 3 knots. Which means we now have our we now have our distance of 45 nautical miles. We have our boat speed that we were given in the question as 12 knots, and we now know that we'll have a 3 knot following tidal stream. So we add the 3 knots to the 12 to give us 15. We have our distance, we have our speed. Now we can determine ETA. By finding out the time it'll take us to get to Farlow from Bramhope Bar. So we know that to determine time, you simply divide distance by speed, okay? 45 miles divided by 15 knots. We don't even need a calculator for that, right? We know that it's 3. So 3 hours is what it'll take us to go from Bramhope Creek to Farlow. Okay, so we take our start time, our departure time of 0755, and we add 3 hours to that, which takes us to 10:55. So we now know, and we can jot that down somewhere, we know that our ETA will be 10:55 at Farlow. Right. So we need to know whether or not we can pass under the rail bridge to see if we can carry on up to Upper Town Quay. Well, how do we do that? Well, we need to know high water now for Farlow, okay, at our ETA. Okay, so at 10:55 we need to know what the high water is. Plus, we need to add another 20 minutes, because if we're able to do it, it's going to take 20 minutes to get up to the rail bridge. So now we have a new time of, where are we here? Of 11:15, okay, at Farlow River. So we need to find out high water at 11:15 at Farlow. So what do? We do the same thing that we did at our departure point. Okay, for Bram Hope, we needed to find high water. We need to do the same thing for, let's go to, for Farlow. Okay, so we go to Farlow, and right away we can see it's a secondary port, and we're told to go to Namely, which is a standard port. Okay, we go to Namely. Okay, and we are going to do the exact same thing, guys. Now, I'm not going to go through it all and bore you guys because we've already done it for Victoria, but it's the exact same process. You find your high and low waters for the morning, you subtract low water from high water to get your range, find out if it springs or not, then you move back to Farlow, you calculate the distances to get your high water. Now, in our case, our high water, after we made the calculations, let me see, where are we here, was our new high water, after we calculated in the differences, 11:15. Am I correct about that? The height of tide, after we've calculated in the differences, 11:15, and the tidal height will be 4.2 meters. Okay, so in order to calculate whether or not we can pass under the bridge, we carry on straight up to the bridge and pass under it to get to Upper Town Quay, we need to now factor in our air draft and a couple of other things. Okay, so first thing we do is we need to go over to, back to the almanac here, the training almanac, and go to our tidal levels table. We go to Farlow and we see that it's 5.4 meters. Okay, that's our highest astronomical time, the highest possible height of tide. Okay, and we jot that down. Okay, we jot down the height of tide that we figured out at Farlow River, okay, which is 4.2 meters, and we subtract that from the highest astronomical tide of 5.4 meters to get 1.2 meters, okay? And this 1.2 meters is actually our fall of tide, okay? So we then add our fall of time, okay, our fall of tide, okay, 1.2 meters to the charted height of the rail bridge, which is 4 meters, to get the height of the bridge at 11:15, which is 5.2 meters, okay? So we're seeing it again here. So 1.2 meters is the fall of tide. Add it to the charted height of the bridge, 4 meters. We get the height of the bridge at 11:15 of 5.2 meters. Then what we do is we subtract our 4-meter air draft from the height of the bridge at 11:15, which is 5.2 meters, to get 1.2 meters, okay? So 5.2 meters minus 4 meters gives us a clearance of 1.2 meters, okay? So we've answered part C by saying, yes, we can, once we arrive at Farlow, continue on under the rail bridge and carry on to Upper Town Quay. Okay? And that's how a question like that is done.